Since I won't be able to stream tomorrow, we'll just do a quick stream today. Quick doesn't necessarily mean the stream, or the VOD if you're looking at the VOD, which you probably are, is on the shorter side. I honestly don't know how today will shape out. I'm not 100% prepared. This was more of a last-minute decision. So, last time I demonstrated online editors and some features of the compiler, how to read messages returned by the compiler, primarily error messages, and how to interpret these messages, how to fix them. We looked at some classic examples where in the past I demonstrated things that don't work, and you've seen how the compiler phrases that. Now we're gonna start by creating a little class. Let's just step in right away. And we're gonna start this series of Old Man Tries to Be Relevant. So I'm phrasing everything now with examples that seem like I'm creating a game, even though it's clearly way too primitive. All an effort to make it less dry. Worked last time. Kids love me. Now I want a player class, because my game needs players. And let's see, I get a player, or plexer, player, and it's gonna be a new player. Okay, so far so good. The basics are there, we have now a class player, and up here I'm creating a new player. I'm using the new keyword. This is a class, so we're telling the system to reserve space on the heap. Exactly enough space for one player, which doesn't really take any space right now. And as part of the initial setup, we have to call a very special method, the constructor, which we do here, which specifies we use the default constructor, which is automatically there. Even if we don't specify one, it's automatically added. It's just the constructor that doesn't do anything. This one. Let's expand this class to actually have something in here. Players need health. That's such a classic trope. I mean, health is so baked into everything. We need health too. And we should probably build that from the constructor. Like that, and then we can start a new player with 999 health. Very simple. To change anything, I could just go player.health minus equal 10. For example, I'm reducing health by 10. Just going to health directly, reducing the value by 10. Now health is 10 less, or maybe 10 more. Whatever I want. But I don't like how I could do just this. Because now my player health would be negative. 999 minus 1000 is minus 1. Negative health. I don't want that. I don't like the idea that health is negative. I potentially see issues I run into down the line, and it seems wasteful anyway. So why bother with negative health? How can we prevent this from happening? How can we prevent negative health from existing? Well, right now health is an integer. Int is a 32-bit integer number, where 31 bits determine the value and the 32nd bit determines the sign. Well, technically not really, but sort of. We have a sign bit anyway. It's a signed value. It has a counterpart, the unsigned int, And the unsigned int is always positive. So by changing from int to uint, we guarantee that health is always positive. Or 0, which I'm counting as positive right now. So we have a system where my health can only be positive. If I were to try to set my health to a negative value, the program will complain. The compiler would allow this right now, because I'm just subtracting a value. Well, kind of. But the point is that in the end, if I ever reach a point where my health drops below 0, I get an error. And then I can deal with that. It's not supposed to happen, so I get an error. That is okay. That's where error handling comes in, which is a topic for a bit later. So this player is now guaranteed to have always a positive health or just 0. But I want something more comfortable than dealing with health directly. Let's add a method called heal, which will, let's also use a uint, amount, and this will just increase health by amount. So instead of doing this, I can just go for heal 10. Looks a bit better. What's bothering me now is if I do this, my player just gets ridiculously high amounts of health. I don't like that. Players should have a very defined cap for how much health they can have. They should have an upper limit, a max health. How can we accomplish that? Well, seeing how we already outsourced the increasing health into a method down here, why not make use of that method and make a little check? Actually, no, let's do this. We increase the amount, but then if health is greater than 1000, so if after increasing the health we go to, actually greater or equal to, let's do greater or equal to above 999 health, we reset health to, no, let's go for 1000. Let's not go for 999. That's kind of, I mean, it depends on the system. This means only 3 digits are necessary for UI, but we don't live in a time where pixels are, I mean, depends on what you do. Pixels used to be very expensive commodity because they take up so much space on your screen. You had very limited amount of pixels to show stuff, so needing only 9 digits instead of 4, that's quite a reduction. Especially if the health doesn't go much above 999, like 1000. That's 1 extra digit for only 1 specific amount of health. So that's why old games always, or not always, but a lot of old games had caps where you ended with 9s. 999, 999, 9999. Just make sure that the amount of digits is small. We don't have that issue anymore, so we set 1000. So I can heal for 1, and we would go to exactly 1000. If I heal for 1 again, well, then health would increase to 1001, which is greater than 1000, so we drop it back to 1000. So this first one increases health, this second one is just ignored. Same if I do this. It will increase health to 1001 and then drop it to 1000. So it's using whatever it can and the rest is just lost. Bad efficiency, but We now have a lower cap, which is 0, because we can't go negative, unsigned. And we have an upper cap because health cannot go above 1000. Maybe I changed my mind. Maybe I do want the cap to have 999. So I go back to my code and I change that out manually. And both of these, which is fine right now. But maybe that health cap is used for a few more calculations. And maybe not just here. What if I have... Restore? That seems like a good name. Restore. 999, like so. We have a certain maximum amount of health that right now is written everywhere in code. And whenever I change it, I have to go manually through my code and change it. And I have to keep track of which number is meant to be the actual maximum health and which number is just the same number but has a different meaning. Like my max health might be 999, but maybe I start only at 100. Who knows? One way to deal with this is something you've learned about. We just create a variable for max health. Set to 999, so we could use max health. Like that. And to make sure that it's always 999 and we don't accidentally just increase the value intentionally or unintentionally, we add the keyword const to make this a constant. So it looks like a variable, but actually the compiler will simply drop this and replace the occurrences with the actual number, as if we never had the constant in the first place. If the compiler changes all of that once the program is compiled and is running on your PC, this doesn't exist anymore. It's gone. That's if it never was. Constants. We talked about that. I can add the same in here. So I can make sure that this also has always the maximum health that I need. Of course, I still have to change the value in both of these methods, which, if we put them at the top of the method, which is something I usually do, it's not that hard. You just go to the method, the first line already contains the necessary constants, and you can adjust. Quick and easy. But these are always the same values. There's an easier way around this. Let's for a moment pretend that this is not a class. Let's just think this is regular code that just has some scopes. We open a bracket, we open a new scope, everything that happens inside is still happening, but all the variables and constants we define are limited to that scope. Right? Ignore that these are all methods, including constructor. Again, it's the constructor. I say again, I don't think I mentioned it today, but I mentioned it a few times when we talked about that. Constructors are also just methods. They're just special in a way, because they only get called once, only when the object is created. Still a method. Now if we pretend these are all just scopes, which they are, kind of, then the way we could make sure that this variable, or const more specifically, is available in both of these scopes, can just define it before we enter the scope, which we usually don't do in between here, but up there, where we also define the different fields. Now we have, if you still think of this as just normal code with different scopes, not as class, then we have defined a variable or constant, more specifically up here, which is available in this scope, in this scope, and in this scope. So I can create a const that is applied to the entire class. Everything in between these two brackets has access to max health as the constant. And the rules still apply. The compiler will, when compilation happens, drop this and simply replace the occurrences with the actual value, whatever that was. And this is the program that's getting compiled. Player will still have just one field, health. And these will just be numbers. But whilst the programmers, before compilation, it's more like a variable that we can reference and make our life easier with. And another cool part about having const inside your class like a field is, just like with static values, you can just use class name dot max health to get the value. For example, reference it in here to create a new player that starts out with the maximum health a player can have. So in that way, const acts similar to static. Only static is an actual variable actually there in your computer memory when you run the program, and you can actually modify it. This is a const. It's not really there once you have the program done. But from the outside, it looks very similar to a static. There are other differences that will become important soonish. But you can access it the same way. Class name or struct name if this is a struct. Same story. Struct dot constant. Useful little tidbit. So we have a constant for the maximum health, and we have methods that use that maximum health to deal with little quirks of how we handle health in a player. Let's say we want to upgrade our game a bit. Players cannot just be one single thing. They might be able to choose different classes. That's a classic move in games. You have different classes to choose, and those different classes will have different bonuses and deficits. And one might be the health, specifically the maximum health. Maybe I have a tank, which will start out with a lot of health. And okay, I'm constantly trying to make the key combinations I would do in my IDE. Of course, they don't work in here. And we have a DPS, the glass cannon, which hits hard but only has 99 health, quite a bit less. And I want that to also be the maximum health. I want the tank to go up to 1000 potentially, or well, 999. And I want the DPS to go at most to 99. But max health is a constant. I can't change it. Max health will always be the same value, regardless of if it's the tank or the DPS. They both will use the same value, 999. So if I want this to be correct, if I want this distinction to actually work, I can't make max health a constant. Just, I can't do that. I have to make that a regular field. Alright, let's do that. Max health equals health. Let's make it so that the initial health is equal to the maximum health when we construct the player. So this will actually work. Clean this up a bit. Okay, and so let's then change this to uppercase to make clear that this is a field and not just a variable somewhere inside the code. It's just a coding convention, specifically a coding convention I'm used to. It's not required to do it. The compiler doesn't care what you call these, like, at all. As long as you don't have conflicts with other keywords and reserved names and whatnot, you can write this whatever you want. Like, the compiler doesn't care. This would be perfectly valid name. But for me, with my squishy human brain, I like that phrase, I rely on coding conventions to make things a bit easier. And now I know max health is a thing I have in this class, a field. I should have named this uppercase as well when I made this a const, but too late. But this presents a new issue. Let's say I have some special effect that buffs the health of a player. Something that goes beyond the normal heal. Well, I could do tank.health plus equals 1. Pitiful, but could work. Let's say this is somewhere in my code. And let's say I make a mistake and accidentally do this instead. Instead of increasing the health, I'm increasing the maximum health. Which might be a legitimate mechanic, sure. But in my case, that was a mistake, that wasn't intended. The max health isn't supposed to be modified. The player is supposed to start with a certain amount of health and a limit to how much health they can have based on their class. So changing this is not a good sign. Don't want that. What can we do about that? Well, I could make it const again, but then I'm limited to the same maximum health for all players, though it will stay constant. That's what a const is. What else did we learn? Well, we learned about static, but static also doesn't help because it just means I can modify this value and it will modify it for every player. And all players will have the same maximum health still, so that doesn't work either. There's another keyword though we can use, one we haven't seen so far, which will magically fix our issues. This keyword is read-only. Using this keyword, we will mark max health as read-only. As in, you can read it, but you cannot write to it. What that means is, this code will not work. The compiler itself will complain. It will see maximum health, it will see it's marked as read-only, and it will see we're trying to change it, we're increasing the value. And it knows this and this doesn't work together. You can't change a read-only value. Not allowed. So the compiler, before you even run the program, before you even get a program, will tell you clearly with an error, can't do that, not allowed, you made a mistake somewhere. Either this isn't supposed to be read-only, or this code is not intended to be run. And then you might notice, oh, right, yeah, sure, I wanted to increase health, not maximum health. My bad. And the compiler is happy again. But as the name suggests, read-only only means we cannot write, but we can still read. So we could do something like if tank.health less than dps.max health. If for some reason we get a tank that has less maximum health than a DPS, maybe there's some concept about level ups where you increase your maximum health and maybe some special things you can do. Then we give a bit of pity help to the tank. There. Get some extra health. Just to keep up with your DPS. To be still somewhat useful. I'm sorry. Now let's build on top of all of this. Let's assume you have made a larger program now. Player is just one of many classes. And we assume there's some other code on player as well, and some other code everywhere else that interacts with player. And you add some new mechanics or new features that interact with the player's health. And, well, heal and restore don't quite cut it. So you simply write your own little piece of code that will go s.health is dps dot. Actually, let's do something semi-complex. We increase the health directly by yes dot max health minus yes dot health. Like that. We make a compilation? Why am I thinking compilation? Calculation. And directly increase the player's health. Maybe this is a bit too simple. Maybe do something more complicated. Different shortcuts or no shortcuts. So get a grip on that. Maybe this will increase by... Oh, actually, what about this? Tank dot health. Then tank dot health equals 0. That's fun, right? Somehow the DPS zaps all the health from the tank. Okay, let's be nice, except for one. One health remains. The ultimate sacrifice. Well, not the penultimate. There's still one health left. And this is part maybe of a script for a specific boss battle. Like a unique mechanic that only exists in that one place, so you don't bother adding it to the player. You just code it directly, because why not? It's there. Well, this can actually cause some issues. Especially if you think about code like this beforehand. See, what happens here is the DPS gets healed by whatever health the tank has, which is probably more than enough health to go above maximum health. There's a pretty good chance that this line will cause the DPS to have a lot more health than they're supposed to have. Our understanding so far of player was maximum health is the maximum health. If it's greater than maximum health, we will cap it at that. It cannot be greater than maximum health. That's how we designed it. That's how we design player, and that's how we write code. We make that assumption, this will be greater than this. Rely on that fact. Only it's not really a fact, it's an ideal. There can always be intentions that are missed or ignored. What happens when health is greater than max health? Well, this would be a negative number. That alone would be kind of weird, because now we increase health by a negative value, so we actually decrease the health, which is definitely not what we intend with this code. This is supposed to definitely heal the player. And now it's actually zapping health. So that would be a bug. But we prepared for that. We made health unsigned, so this cannot be negative. So what happens instead? The runtime will notice I am subtracting a big number from a smaller number, which will lead into a negative value that is not possible, that we prohibit those, create an error. Your program will throw an error, which in the worst case will crash everything. Unless you have some decent error handling, again. You know, I notice I say again quite a bit. Is again my new actually? Why is it always the ace? Always. That's probably the next one. So this might actually cause an error because this breaks the internal logic everything else, including this line, is based upon. We're not supposed to write this code directly. We're not supposed to interact with health directly because we might break the rules. And once we break the rules, everything else that is based on those rules, that relies on those rules maintaining integrity, will break as well. And it cascades from there potentially and completely crashes your program or does even worse. Like, I can deal with my game crashing, but if it's corrupting the save game I put hundreds of hours in, that is rage. Or frustration. It's definitely a sign for I'm not gonna play again. So, how do we deal with that? Well, the direct solution to this would of course be using heal. So instead of adding directly to health, we're supposed to yes.heal. Do it like that. That's what the heal method is for. Call the heal method, and it will ensure that max health is the maximum health and stays that way. So this code will still work. Of course, we're also not supposed to do this code. We're still supposed to call the method. The point I'm making is, code like this is way too convenient to just write out. Especially if you're prototyping or testing things, you might leave that code in because you're too lazy to figure out how to do this properly. And right now, healing is fine, but setting the health to exactly 1, we can't really do that easily. We could calculate based on the current amount of health and then add a negative amount that gets to 1. But this is so easy to do. And I'll fix it next week, I swear. We're still in beta phase. We're totally getting rid of that later. Just like the other million to-dos that we completely forgot about. Ideally, we will make it so that I can't just set health to 1. I don't want anyone, including myself, be able to just change this value by their own standards. I want it to always happen using the rules established in player, so we can all agree on how player works. Player contains all the logic, and so player is the only one that can commit to a specific value. The logic in here is consistent, and so as long as we only use the logic in here, player will not corrupt anything else. But it is right there. I can just change the value. It's just a field. I could do the same trick as with a maximum health. Change it to read only, but then it's read only. Read only cannot write the value. Oh, right, I think I didn't mention that before. The constructor is again a special boy and gets to write to read only variables. It's the only case where that's possible. Read only can technically be written to, but only once. Only inside the constructor call. Once we leave the constructor, no more changing that value. Once this is over, once the constructor is done, those values stay the way they are. As long as we're inside the constructor, we can set it to whatever we want as many times as we want, if we want to. So health could be set to a specific value here, and I won't be able to change that with like. Obviously, for maximum health, that is fine. Probably for the actual health, that's an issue. We need to change it. At least player needs to change it a few times. We only want others to be prohibited from changing it. And for that kind of scenario, there's a concept in C# that's present in a lot of other languages as well. Like, this is not a unique feature to C#. I'm just talking about how C# is doing it. And the idea is that we can mark code as limited to a specific scope, in a way. Earlier when I demonstrated the const, I told you, imagine this is normal code, and this is just code blocks inside our normal method, and we have a scope here. So the maximum health in here was created and then forgotten once we left the scope. And then once we got down here, we had a new constant, maximum health, which was only in scope until we left this block down here. But then you think about fields. I have this field health and this field maximum health, which are defined inside this code block, if you will, this class. And yet I can go in here, in this code, and reference that. I can access health. I know health exists. I can see health. I can see maximum health. Even though it's technically in this limited scope here. So obviously, fields do not follow the usual route, which makes sense they can't. I have to interact with the data in here. That's the whole point of custom types. Sort of. So fields break the rules of scope by allowing anyone outside of the scope still to interact with them. But I get to control this interaction. I can say this variable is not accessible, or this variable, this field, is not accessible on the outside. Or I can say it is accessible. I get fine control over which fields can be accessed, which exist outside of the scope of this class. I can set the visibility. I can determine the level of visibility for different scopes. And there are a couple of different layers for this visibility, but we don't need to talk about those yet. That's only relevant much later. There are only two you need to learn right now. And both of these are determined using a specific keyword each, which we will put in front of our fields. Now for maximum health, that is a field we want to see in this other scope. We want to see it everywhere. It's a read-only already, it's protected, we don't have to worry about anyone messing with it, so let's just let anyone see it. We don't care. We go public. By adding the keyword public, we tell the compiler it is fine for everyone who has access to player, everyone who knows player, like we do up here, to just access the field maximum health. And so we do. No problem. Health, however, is something we want to limit in visibility. We don't want everyone to see it, because it's too dangerous. They might not understand the logic for a player, they might do things that are not allowed, that potentially break things in a way that we can't anticipate beforehand, and that we don't want to keep track of every time we use health. So we make health private. Max health is public. It can be seen everywhere. Health is private. It is limited to this scope. It's only known inside player. This code here doesn't work. Player.health is inaccessible. As far as this code up here is concerned, health doesn't exist. It's as if there is no health. There's no field called health. There's only a field called max health. We don't see anything else because it's kept private. It's kept hidden. You open this bracket, you enter the scope of this class, you have understanding of what health is. You leave the scope, it's gone. No idea. Max health is public, we can see it everywhere, we can just not write to it. Health, we can read and write, but only inside our class, because only here it's within the scope. It's actually a very simple concept, but it has major implications for how you write code. Lots of implications, and there's a lot of code that is built around dealing with those consequences from making things public or private. The first consequence is, how do I see how much health I have? Health doesn't exist, it's private. I can't see it up here. It's the same as that field doesn't exist. I don't see it. And the same as health. We know technically there is a field called health, but as far as the code up here is concerned, it's the same as attack strength. Doesn't exist. So how do I know how much health I have? I can't see health directly, but I can still ask player to give me the amount of health it has. Can't read it directly. I can tell someone to read it for me. So I could go int get health, and let's move to the next line. This will return health. And instead of health up here, I use get health. You get health. Up here, we call the method getHealth, which internally will do nothing except read the value for health and return that value. Remember, health is not visible to anyone outside, but it's perfectly visible in here. So getHealth, the code will see we're referencing a field. It will now go and read the value on the heap, the actual number that is stored in health, which could be anything. And that number is then returned from this method. We're not breaking the private part. We're not returning health up here. We're returning only the value that is stored in health. That's a big difference. We don't get access to health on here. We only get to see the same value that is stored. We copy the value basically. But up here, we still have no concept of this field. We can't tell if we're returning a field down here or just a constant value that we just made up. We don't get to see that difference. We don't care. We get a value, that's it. And it's just by convention that we know it will be the current health value. Convention being, this is a getter method. There's a specific term for this, the getter. We have a private, a hidden field that we cannot access directly, so we use a method to get the value for us. And they're usually called get, followed by the name of the field. Right now, the field is health, so the method is called get health. We could also have a get max health if this was private. Don't need that because of the read-only, but we could do that. To make this code possible, we would need the counterpart to getter method, which is called a setter method. Would set health. It's the same schema. We just start with a set instead of a get, and still followed up by the name of the field. And also with get health, we don't provide any values, we just get the value back, or a copy of it at least. And for set health, we don't get anything back, but we input a value. Let's just call it value. Now we can set health to value, like so. And call set health up here. With this, we basically get the same effect as with just the health field directly. But we can still read the value, we can still change the value to set it to something else. We just do it indirectly. We let some methods in player do that for us because we don't get access to it directly. We just give someone a slip, here's a number, please pass that on to superiors to store that internally. And so the method does. Or we can knock and ask very nicely to please give us a copy of whatever value is stored for health. The whole point here, however, was we don't want people to just set the value, which we still do with this. The point of the setter method, the indirect method, is that we can now add additional logic that is guaranteed to be executed when we set the health. So player still has full control over what's going on with this variable, with this field. I can change it, but whenever I change it, I apply additional logic that makes sure we don't go over the cap. And now we see some code here that's doubled up. Well, there are two ways we can go about this. Actually, not two ways. There are a couple of ways we can go about this. One might be void cap health to max. Let's put it like this. We just create a method that checks if health is greater than max health. Then health equal max health. And down here, we simply call the method internally cap health to max. Like that. And we can do that in here as well. Like that. So this method is called every time we do, and it will make sure that health is capped to a maximum, without us writing the code several times. Don't need to do that here because we already keep the rules in mind, though in theory we could do something crazy. Don't need to. That's one way to do things. That introduces some weirdness up here though again. Because now I can just do dps.cap health to max. I can call this method on a player and it will just make sure health is not going over the maximum, which already happens anyway. Any method that changes health automatically calls cap health to max. This method call is perfectly fine. It's legal. It's not doing anything wrong. It's just unnecessary. And it might give someone who's just seeing the code for the first time, who's just going over the different method names, the idea that they might need to call this sometimes. By the way, another feature of editors, sometimes quite useful, you can fold these in, save some space. Can be quite useful. Anyway, capture health to max is visible, we can call it, but it's pointless, and it might communicate to another developer in my own team maybe, or just to my future self who forgot most of the code already. You need to call this, maybe. Well, it's important that you keep track of this yourself, which is not the case. Ideally, this method that is definitely needed internally here should not be accessible to anyone outside of our player class. That's a concern that player should have, not I as the programmer in main. I don't want someone to call this method. I don't want them to see this method. And how do we prevent people from seeing something in our class? We hide the visibility by marking it private. Visibility doesn't only apply to fields, it also applies to methods. By marking cap health to max as private, it means the compiler won't let me call this method. There is no public method I can access, there's only the private method I could access if I'm inside player. Unlike setHealth, which definitely is a public method, and heal, which is also a public method, and restore, which is also a public method. And so is getHealth, and yes, even the constructor has a visibility, also public. If you remember last time, we had an error message. I didn't want to go into too much detail. That said something about accessibility. And that was because I just created a class with some fields, as you should have been used to by that point, which automatically assigns a default visibility. Similar to how a default constructor just exists, the visibility for any method or field has also a default value. If you don't provide one, if you don't set anything in front of here, the compiler will just assume a specific type of visibility. And for the fields and the methods, that was private. So doing it this way or leaving it out has no difference in the end program. It will behave exactly the same. Health by default is actually private. So adding private right now is not really changing how health behaves as far as the compiler is concerned. It's only helping us keep track of, oh, it's private. It's a private field. We can't see it outside. Public has to be specified. If I don't add public here, maximum health, well, I can't access it, can't see it, not allowed. Because by default it assumes private. We have to make it public explicitly. And now we get to actually access this field from the outside. The visibility, the accessibility, if you will, also applies to statics. If I make something static, it will have the same rules for can I see it, can I use it. If I make something private, it doesn't matter if it's static or not, I can only see it within the class. If something is public, it also doesn't matter if it's static or not, I can see it everywhere else. So you can make public static, for example, or private static. and the visibility would be the same. Health can only be accessed inside class, player, and max health could be accessed everywhere. So this method up here, well, we should probably also mark it as public, because the computer is going to call that, so the full signature should be public static main, to be more exact. It's okay, it's not really needed, but it is the more traditional correct-ish signature. It's usually the public static void main, though you could get away with just the static void main. There's a lot of things that happen automatically. And I think we're already done. I wanted to tell you something else, I forgot it. What was it? I suddenly got into the statics and then I forgot what I wanted to talk about. I didn't want to talk about properties yet. There's some other stuff I want to discuss first. With the read-onlys, we had the public and the private. Right, we should... right, that's it. Naming conventions. So, max health is a public thing, public field, anyone can see it. I keep it uppercase. Big M, capital M. This is a proper field, just like the different methods are uppercase. This is definitely part of player. That's officially used and defines what a player is. When we have values inside different variables, we write them lowercase because, well, they're just some name, temporary, they don't exist for long, they only exist inside this scope and then they're gone. Not too important. I said private makes this field behave like it applies to a normal scope, even though it's not normal code in here. It means this is limited to player. So we write it lowercase as well. Just a naming convention. And on top of that, we would add underscore. So this is more what the code would look like. Thought process is, this is private, this is hidden. If I were to write help like this, the compiler would complain that I can't access this, and you don't even need the compiler. You look at this code and you automatically see something is off here. This looks off. This doesn't look quite right. Dot dash something, it's... No, I don't like this. So it's a very effective way to make very quickly clear that this can't be correct. Also looks a bit weird in here, but at least there's no dot in front. As long as you're inside the scope of wherever defined it in the struct or the class, you only have the dash in front. It still is useful because now you can differentiate between this is a variable inside this method only. It's lowercase. This is also lowercase but has a dash in front, so this is actually a field. This is a field, it's uppercase. This is a field, there's a dash. This is uppercase, so it's a field. This is lowercase but has a dash in front, so it's also a field. This is just lowercase without a dash, so it's just a local variable. dps.max health, it's a field, no problem. The dot dash, this is a mistake. This is not supposed to happen. It's just a convention that's very useful in making code more readable instantly without having too much context. For methods, it's the same idea, though with methods you get always uppercase. Difference between fields and method is that you have brackets after the name, so you can differentiate between fields and methods quite easily outside. For some reason, the convention doesn't extend to special syntax for methods inside, so you don't write cap health to max, though you could. I don't think I've seen that so far. But then again, there's no chance of mistaking this for a variable local one. So inside, it doesn't matter if it's private or not. On the outside, you don't see it anyway. And you just deal with the error that might come up with you call cap health to max. And I think that's where we stop for today. It was a shorter one after all. Actually, you know what? No. Let's do this one as well. Public. Because we have some time, let's talk about that. Because it's a bit weird, but it's not that complicated. Fields can have visibility. We are limited to the scope of the custom type, class, struct, whatever. And methods, including constructors, have visibility, accessibility. That limited to the custom type or go public. And custom types themselves also have visibility, accessibility, and accessor in front. That limits where we can use it. It's just with custom types themselves, with classes, it's a lot rarer that you do something that's not public. At least considering your current knowledge of C# programming, you will basically do everything public. You can imagine that everything we did so far with custom types, every class we made, every struct we made so far was always public, basically. You could make private. So I told you last time or the time before that we can have classes inside classes inside classes. So I could make public class. Let's make class attack for some reason, which has public read only. Let's apply what we know so far. Uint strength. And maybe public read only uint cost. Let's say every attack has some cost associated with it. Maybe stamina systems or whatever. Or maybe a system where you actually have to pay for each attack. You throw gold? Like, I think that's a mechanic that I've seen a few times. You use your money directly, like throw gold coins or convert those into attack strength. Or maybe a blood cost, you pay with health. Could be different things. And yeah, now we have a class attack inside the class player. From the outside, I would go player.attack. A equals new player.attack. I still have to use the dot syntax, the dot operator, because this is in a way similar to a static field. This is a static, this is assigned to the class player. This is part of player. It's inside the brackets of player, it belongs to player. You can't have it without player. So you always start with player dot. But after that, well, this is a class, a custom type. Everything after that is like a normal class. Just have to make sure that you always add player dot in front. That's all. Otherwise, this is now a normal class. That is, until you have two things. First of all, maybe that's... Actually, no, let's... No, we're doing this. We have time. Public void get it. Attack. Alright, so a couple of things straight up. I only said attack here. I didn't say player.attack. I didn't say player.attack because we are already inside the class player. We're inside these brackets. I also don't need to say player.help in here. I can just say max health and health. And the same way, I don't have to do player.attack because we're already inside player. Player dot just means, okay, shift focus to inside what's before. Dot is always take whatever had been placed beforehand and go inside of that. Go specific to the scope of inside whatever was before. We go to player, we go inside player, inside the scope, and then go to attack. Attack, this class, alright. But now we are already inside player, so if I go attack, I just look on the same height, on the same indentation here, and I find attack. They are siblings, so to speak. They're next to each other, both in player. So I can reference it and the compiler knows exactly I mean this class. Next. I can public, actually no, let's do the blood cost. Public void apply cost player. Things get a bit complicated now. Player attack, which I'm gonna do public attack in strength and wait, sorry, uint, we're doing it unsigned, and uint cost, like that. And then we set strength to strength and cost. I can type cost equals cost. That's what you get when you get spoiled by autocomplete. And I mean actual autocomplete, not AI. Which is also autocomplete and dumb, ironically. One of the first things I did in my recent upgrade to a different editor, turn off the AI autocomplete. It's actually not that bad of an idea, but the suggestions were just, they were so dumb. Like, AI is supposed to be this cool, smart tool that developers use to be so much more efficient. I spent all my time just face palming on the suggestions the AI makes. It's, ugh. Plus it takes forever. Good old IntelliSense would just take a couple of variable names. I type something that sounds remotely like that variable. Might I suggest this variable? Anyway. Where was I? So we have a new attack. Let's say that does 50 attack and costs 5. Let's do that. Now if I look at just the class attack. Ignore that we're inside player. Look at only this code. It's just a normal class. We have two read-only fields. So I can create a new instance of that attack class. 55, 50 and 5. I save that in these fields, and these fields cannot be changed afterwards. So A will be locked into 50 and 5 respectively for strength and cost. And then I can call A dot apply cost. I could enter the DPS, and this will call this method apply cost on an attack with 50 and 5. And the player we get is our DPS player with 99 health. Well, actually, it's yeah, not healing anything. This will zap all the health from the tank, but we already had full health, so yeah, we had still 99. Apply cost will get the player. Actually, let's drop this down here. Apply cost lets us do something we thought we eradicated. Player dot health reduced by cost. This is legal code. I can't do vs dot health minus equal a dot cost. I should uppercase cost like that. This is illegal. This is legal. This is flagged by the compiler. Can't do that. This is fine. Now here's your question. Why am I allowed to do this? What does private mean? What does it do? It privates this field. That means it will limit access to this field, the visibility of this field, to inside the current scope, the class player. It will limit access to it to inside these two brackets. And what's inside these brackets? Well, besides other things, it's also the class attack. So this code down here is inside the scope of the class player. We are inside those brackets. We are also inside the scope of the class attack. But both can be true. I can be in two classes at once. I am right now. I'm inside attack and inside player. And so the class attack actually has full access to all the private stuff in player. Meaning we can do this. We could also do cap health to max. We could also do that. Even though we are subtracting right now, so it doesn't really make too much sense. What we should probably do is check for the current health and make sure we don't go negative, because that might still be an issue. If player.health is greater than cost or equal to cost, let's say we can go negative, not negative but 0. Now let's say we go, it's greater than cost, we can subtract it, and else we just go to player equals 0. Let's do it like that. So we cap it at 0 just without the capping mechanic, because we don't have negative values. We can just set it back from negative value to 0 up. This will work true. So private limits to the scope of wherever we define it, but this might include the scope of another class which overlaps with the other one. This might be child class. And so even though we are not directly in class player, as in I don't have access to health directly or max, nope, there we go. I don't have access to max health. That might be maybe the difficult part about this. It's not like we are inside a specific player. Class attack is more like a static. It's not tied to tank or to DPS. It's like a static field, like a static thing, method, whatever, that exists globally, not tied to a specific version of player. So max health is not accessible to us because apply cost is not itself tied to a specific player. It's just tied to player in general, the class. Indirectly because it's tied to attack. It's the method of attack, and attack is tied to player. So we still have to provide a reference to a specific player, but then we can do max health. And health as well. Being inside the scope of another class doesn't mean you tied to a specific version of that. It's not like every player now internally has also values for strength and cost. There is no field called attack inside player. This is like a static definition. It's not a normal field or anything. Just a child class. A nested class inside player. But because it's inside the scope of player, it gets the privilege of accessing private data, private methods, private fields that anyone outside of player would not have access to. And since we are a nested inside player, that means we can change this to private as well. We now get a private class. And being a private class, the outside world doesn't see us. As far as our main method is concerned here, this class doesn't exist. This is gone. This is private, this is hidden, this is not visible. So this code is not allowed. We cannot create a new instance of attack or use it because there is no attack class visible. It's private. Player itself has access to attack. So we could, if we wanted to, store attack store private version. Let's be very creative. Health divided by 10. Health divided by 100. Right. So this might be private, but it's private only inside the class player. We are down here inside the class player, so we can see the class attack. We can use it, we can reference it, we can call fields on there or call methods on there. As long as we're inside player, we can see attack. And as long as we're inside attack, we can see player. The outside world doesn't even know that attack exists. We do. And the outside world doesn't know this field health exists or this field attack. Attack does. You might be wondering, why bother with public? If the attack class is private, then surely these could also be private, right? Why bother adding public to this? Doesn't matter. Well, if we put this in private, that means we limit strength to the current scope, which is attack, to these two brackets. Outside of that scope, and the rest of the class player, attack.strength. What am I doing here? Alright, so my keyword layout changed. That's better. Attack.strength. Not accessible. Because we made it private. It's inside a private class. That's not an issue. This private class is on the same hierarchy level as we are. It's private to player. We are currently player, a player, inside player, so we can see attack. But strength is not on our level, it's inside attack, it's deeper in the hierarchy, further down. And it's privated in there. Only visible inside this highlighted area. So strength is not visible. Cost would be. That's fine, because it's public. So these accessibilities, these visibilities, do interact with one another to a degree. We say it's public so everyone can read it or see it, but then level up, we say, no, you're private. So not everyone can see it. So everyone that's able to see this is able to see it, which doesn't make too much sense, but if you can see attack, you can see cost. But to see attack, you need to be in player. And you can stack this up a bit more if you add some different visibilities. Because, as mentioned a bit earlier, these two are the most important ones that you need to know, that you need to work with. But there are other visibilities that you can use that have specific effects, that have other ranges. There's more between no one and everyone. And they can all mix and match, especially when you start nesting classes or types in one another. A lot of my time, actually, when developing new code, new libraries especially, is figuring out what do I put to the outside, what do I make visible to my colleagues, and what do I keep hidden. Because you want to keep certain logic internally, because they don't have the idea of what this class exactly is. They don't understand the internal logic of how everything is supposed to work. And they're not supposed to think about that because that's my job. I'm writing that library so they don't have to worry about it. They just get a finished player class that has health and they can change that health, and the logic internally makes sure that it stays consistent and doesn't break anything. So I have to make sure that they can work with it. I do have to make stuff public. They have to be able to create it, and there are some values they should be able to see in some way, and they should be able to use it in some way, but some things are not required for them, which just make things more complicated than it needs to be, or less efficient, and some things should not be touched by them, because if you do not understand the exact logic, it's possible to corrupt everything. So figuring out what do I make accessible to the outside? Do I make it read-only? Do I make it constant? Do I hide it internally? Do I make it visible everywhere? How do nested classes mix in here? Do I make them visible? Is this class useful outside, or is it only useful inside the player? It might be useful outside, but then how do attacks and players interact? What's the overlap between the visibilities of these two? That's what I do a lot of the time. Like min-maxing, just giving everyone enough access to use it, but not so much access that it's easy for them to corrupt data. Like make it as hard as possible to destroy things, ensure that the compilable set very clear limits for them, but also allow them to effectively use it in different ways that I might not anticipate, but that would still be consistent with the internal logic that I made up for player. And for that kind of thing, feedback is also quite useful. If they use your class and they notice, actually I use this in this way and I have a lot of effort I need to put in this other thing, then maybe extend your class, make some things maybe visible, or add additional methods or fields and just change things to make it more comfortable to work with in the real scenarios it's used in. Okay, but that really is it. This is where we stop. I guess if you're the celebrating type, enjoy the holidays if you have them. I know we get 2 days off for Easter, so I'm gonna enjoy my time off with the family. And yeah, have a happy Sunday and Monday, maybe, hopefully. Till next time.